All right, why don't we go ahead and we'll get this started so we can stay on track. My name is Mike Cohorst. I'm a senior account executive here at Crossvale. And today we're going to be, hopefully you guys are in the right spot. We're going to be talking about, changing development, SpringBoot to Quarkus and why that's important. So joining me today is Jose Alonso, and he is our CTO. So with that, I'm going to go to the next slide here. All right, so here's what we're gonna do a quick introduction who Crossvale is, and then we're gonna show some slides on SpringBoot to Quarkus, and then we'll do Jose will walk you through the workshop. So just some housekeeping items. Basically, everyone will be on mute, so use the chat for any questions that you may have along the way, or if you're having issues with the lab. The lab will be open for 24 hours after this commences. We also will provide the slide deck and the recording for this afterwards. So, and Jose will walk you through getting set up for the lab when it comes to that point. So this is what we're going to cover in the next 2 hours. So we have a lot of info, and I will get kicked off here. All right, who's Crossvale? Crossvale is an IT service provider, and we have been founded in 2001. Basically, we've been helping customers through their modernization journeys. And so our team provides expertise in the various modernization initiatives. So we try to find where do assessments with you to find where you guys have gaps and where you want to go, and then we can help guide you through that journey. We have 3 main pillars that we focus on primarily. So around automation, we're trying to drive out the repetitive tasks across the organization, the enterprise, to gain more efficiencies and reduce costs. Another big growing area is the hybrid cloud. We help customers determine where they should run their workloads. Some may need the security and be on premise, while others could be beneficial in the cloud. So hence a strategy to help customers around that. The one that we see a lot of traction in right now is helping customers take large waterfall monolithic applications and breaking them up into microservices to have the whole continuous integration and development. So that's our modern app development, one of our pillars. As I talked about, we have day 0 where we assess and plan. We also have day 1 where we do the build and deploy. And for customers that would like us to help them with their management, we do have a managed service practice. And then lastly, we can help with securing your subscriptions as well. These are just some of our snapshot of our achievements. We're a Red Hat Apex partner. We've been Apex Partner of the Year for the last 4 years running. We're certified in all the major cloud platforms. So with that, I will turn it over to Jose, and Jose will walk through the next portion of this. So Jose, do you want me to stop sharing and then give you the slide deck?
Yes, please, Mike.
Okay.
I'm ready.
Okay, and then let me make you, just a second here. I'll just make you, I'm just gonna make you the host, Jose. Okay, Jose, you're the host now.
Yep. Okay, let me share my screen. Let me know when you can see my screen.
We can see it.
Okay, great. So let me go back one slide. So today we are going to be talking a little bit about what Quarkus is and how can we use it. How can we use it in the in terms of how can we compare it to a known standard like Spring, or for Spring developers, how can I develop applications that before I used to use Spring, but now I want to maybe consider using Quarkus. So before getting there, let's study a little bit what Quarkus is and why do we need or don't this new standard or this new tool. When Java appeared in the 90s, it was a huge change for companies to start adopting new technologies and to be able to develop applications fast, to be able to have something that was portable, that you could run on commodity hardware. It was great, but at that time, the cost of running it was not particularly cheap. So here in the screen, we have a couple of numbers of running like an enterprise-grade application based on Java compared to like if you were running on CICS, on IBM, trying to create the same kind of enterprise-grade environment. You would have a Sun Spark app server for 18K. Then you would have your application tier, your web logic. Then you will have your database, again, the infrastructure, and then the RDBMS. And then you will have the development environments. Well, all of that amount for almost $500,000 in CapEx, not $500,000 today, but $500,000 in the 90s, and $80,000 of annual maintenance, more or less. Again, not every application needed this, but comparing enterprise grade to enterprise grade, this is what the cost of running Java was. And why is this important? Is because, well, when you have a cost of run Java that high, you want to maximize the use of it. You want to use it as much as you can. And for that, you start adding things into the application server to be able to allow for that. You start adding a lot more applications into that application server, into that web logic, more applications inside of that, leveraging the same hardware and the same JVM. Now, that created the situation of having a hardware supporting all that. There was no failure or disaster recovery built into the hardware or into the web logic itself. It was more, or into the operating system. It was more on the web logic itself and the application that was in charge of creating that resiliency. So that made that application server get farther and farther and farther into that JEE that was quite to run because it was providing a lot of functions that were needed for the applications. It was filling a gap between what the operating system provides and what the application is able to do. So it was abstracting all of that thing from the application. Now, during 10 years, that was more or less what was going on. We went from like Java 1.0 to JEE 6 in 2009, and that was a big change. Now, you see here, there is another big change that was the appearances of Office 2. Now, when we put these two together, it changes the approach that many companies took to Java. Since now compute is cheaper to acquire and there is no really payback, there is not really investment, it's just OpEx. We just use it and pay for the use of it. We don't have to acquire it, we don't have to install it, we don't have to rack it, we don't have to do any of that. I just provision an EC2 instance and run my code. That created a change in how the applications were deployed. Now with that change, and we will see that in the next slide, it enabled a lot of modernization and innovation that created the Netflix models, having the Spring Cloud, having Docker, having all of these things were created because of that level of access to cheap resources to run and the isolation of processes, both in the RHEL, in the Red Hat Enterprise Linux, and also on Java. So when we move, as we moved into the, as I was saying, these are the prices of EC2 from AWS, but I mean, if you go to Azure or Google Cloud, you can see that the price is very minimum for running a server. Like, there is no CapEx. I don't have to buy the server. I can just pay for what I use. What that meant is that now I don't care so much about running too many applications inside of one server. I want to have one server per application. So when an application is consuming a lot, it doesn't impact my other applications. It doesn't have an impact on something that I'm not predicting. I can isolate one application into a single server. I can understand it. I can know how much CPU RAM, how many resources is it using, who has access to it, what IP, etc. That enabled the applications to be spread and to run in a different way. Now, this still runs on a the same kind of application server that we were running before. The WebLogic, in transition, it evolved into the WebSpheres, into the JBoss, into the SpringBoot, or the Spring servers. This still is a big memory deployment. Like we are consuming at a minimum 100 megabytes of RAM to run, plus all the memory that we want to allocate to the application. This scaled meant that I had hundreds and hundreds of instances running one application per instance. And now I have to watch those instances, and I can do all of that with tools that the cloud providers give me. But this is something that I have to hack my way through. Now, in the 2015 to 2016, Kubernetes is starting to get adopted. And now we have a better way to manage those things by not going straight to the hardware to install it, but to transform our applications into containers. If you saw in the previous model, you think about it, the application server was not static, it was dynamic. We were injecting changes, and it was a long-lived application server. As we progress and if we evolve, these containers become more stable and more static. They don't accept changes. They are immutable. Once I need to do a change, that container needs to be recreated. So injection of code or injection in a running container is not something that is observed in many companies. So what does Quarkus does? Quarkus, as we decided that we were going to be now static and we are not going to accept changes, I don't need that big JVM running anymore. I don't need the JVM to provide me those functionalities that I now delegating to Kubernetes. So if Kubernetes is taking care of my health checks, it's taking care of my copies, it's taking care of my load balancing, it's taking care of all of those features that are now part of standard Kubernetes, why would I have that as well inside of the gem that I'm not using? But I'm still paying in resources for it. So Quarkus comes to have like a streamlined version of a JVM that only runs for this type of microservices or services. You can create many services with Quarkus. In my opinion, there is a use case for it, and there are some other use cases where it is maybe better to use a traditional web server, like a traditional WebLogic, WebSphere, JBoss, whatever tool you need to use. When we compare what languages are used on Lambda, Lambda is a function or way of creating code in AWS. It's code that doesn't run all the time. It runs when it's needed. So you don't have a JVM running all the time. The executions, it loads the code, executes and discards the codes. And then you don't have to pay for servers or anything like that because you are not running them continuously. 51% of that code is Node.js, 38% of that is Python, and only 6% is Java. So Java is losing, or was losing, this is from 2020, was losing the battle of the functions. When we look at the code of Java, and we go from a full application in a function, something that is executed in just this time and then is discarded, the battle was being like won by Node.js and Python. So, sorry. So Java was designed for that era. It aimed to maximize network throughput. There. It was designed for maximizing throughput on the application and ignoring the resources. Like it doesn't matter. I have resources. We have bought this server. We have all these resources available for the application. I just want my application to run for a long, long time, and I want it to process as much as I can with it. When you're paying that amount of money that we saw before, the goal is to put as much as you can through it. Those application servers, as it had so much, and it has, like even in today's terms, it has so much, it takes a long time to start. It is designed to be a long running thread. It's not something that you start and stop. It is designed to run for days or months, sometimes even multiple months at once at a time. The restarts are not what you really want to do with this type of application. So when you move into an agile world where you are doing deployments continuously and you are doing restart continuously and you are doing, or you want to process functions, kind of like I want to drop an event in a queue and I want this function to be started when there is this event. And then once this event is processed, the function is discarded. I don't have to keep paying for those resources. This is not the right infrastructure for that type of experience. Now, if you want to run a portal that doesn't change, that you deploy once a year and it doesn't change, and you have some users connected to it, not a lot of traffic, and you just to have something running continuously, maybe you have still a use case for a full application server. But what we are seeing in the market is the evolution for from the mutable system that we explained before to the unmutable system. From the big server running into the container world, where I don't want to care for the application. I want to have health checks and have my Kubernetes, my core, taking care of. I need to have more replicas, I need to scale, or I need to keep alive these servers, these services. So what is Quarkus really? Quarkus is a cloud-native microservice development platform that is serverless. What does serverless mean? It doesn't mean that you don't need a server. It means that it doesn't have a server running all the time. It runs only when it needs to run. As you reduce so much the startup time, I think we have a slide later to discuss that. But the startup time is reduced to below second, to sub-second, which means that now you can start, process, and discard. It's kind of like the OSGI version of Java, but applied with a smaller JVM, with this minimum JVM. So if we look at what it is, Java is still one of the most used languages in the world. It ranks like #1 in many portals for developers, in many communities. It is still easy to learn. It is very easy to scale. languages, and it is very easy to adopt as a developer language. When we apply Quarkus, we get this massive performance out of it. Like if you see these three charts that we have here, like this would be an optimized code running on an optimized JVM. This is a Quarkus code running on a standard JVM versus a standard application running on a standard JVM. And you can see the difference between the three. Like not everything is possible to get here. Some will stay here and some will need to stay here as yet. This is not the one solution for everybody. This is not a one size fits all, but for the people or the use cases where it fits, it's a massive gain in performance and it's a massive gain in flexibility. Now, as this has been developed now, the tool chain, it's great. Like it is thought to have the CI/CD. It is thought to have a web IDE. It is thought to have the skeleton, the scaffolding. Everything is ready to maximize the performance of developers. And it's a developer first language. We will show you a little bit of what you can do with it and how you can start with it at the end of this presentation. This is not going to be death by PowerPoint. It's just a couple of slides. And then the community that keeps evolving. There is a massive catalog of dependencies already out there and libraries, and it keeps growing. I'll show you that at the end. So to sum up, huge benefits to use it, great for developers, and also good for operations. The operations, they don't have to care anymore about your runtime running so long or your threads or your thread pool or anything like that. That is being taken care of by by the Quarkus. So if we compare the footprint of an application consuming REST, this is or exposing REST, exposing a REST interface. If we go to a traditional cloud native stack, this would be a SpringBoot. You will take 140 megs minimum to run. If you do it with Quarkus running on an OpenJDK, you just reduce it to half of it. But if you go to an Quarkus optimized JVM like RAL, you go to 13 megabytes. And that is a massive gain when you want to go into the function world. When you have a function and you have to allocate all this memory, the more memory you have, the more time it takes to run. The more space you consume, the more it takes to run. So going to small footprint means that you can run faster, you can load faster, and you can start faster. So taking an example, the same example on startup time, you see that you go from like 0.14 seconds to 4.3 seconds. So 14 milliseconds versus 4.3 seconds. 55 milliseconds versus 9.5 seconds on REST and REST plus CRUD. CRUD stands for create, read, update, and delete. Like this is an application that is writing or reading from a database. Or yeah. So Quarkus unifies imperative and reactive. This means that you still can use your injections. You still can use the same thing that you are using today in your Spring development. It's just that it changes a little bit into a different type of injection. And I think I don't have here the slide. I can show you later the documentation for it. It's part of a workshop that we have. So Quarkus uses a lot of frameworks and a lot of standards, and this still keep growing every time. So for us, for instance, we use a lot Camel. We use a lot the micro profile, and we use a lot Kafka. These are the three main ones that we use, and the rest is. There are some others. Of course, it runs on Kubernetes and OpenShift. It has native access to the APIs that Kubernetes and OpenShift provide. It has provided with Jagger, so you can trace it. It has access to MongoDB. It has access to with Hibernate to a database, to MongoDB. It is very, very flexible as any other Java development application. So how is it different? A difference is that this application, when you build it, it's not only creating the compile, the runnable version of it, it also creates how will it run. So it creates during development time how the application will run. So when it's time to start, it's going to start a lot faster. And these are some examples from Lufthansa, from Vodafone, how changing or adopting Quarkus became so much of a difference for them. And this is how big can you get, or how small can you get in this case. So in the case of Lufthansa, they were able to go 3 times denser on deployments. So they didn't need as much equipment, which means that you don't need as much VMs to manage. That means that you don't need as much space to do backups or restore. That reduces your operations time. Anything that you can reduce is going to help you everywhere. It's not only on the application side, it's on every other process that is to support that application. So if you want to start with this, we have a couple of places where you can go. In Red Hat, you can go and do an introduction to Quarkus. This one is pretty good. I really recommend it. And this, you don't need anything. You just need your browser, go in and do a test. This one is the one I use the most, and the one I recommend the most. Is go and do it. You go to code quarkus.io or quarkus.io and then navigate, and you create your archetype. I'll show you how to do it now. And then, of course, there are the case studies, and there are a couple of books that you can follow to learn these things. Now, we as Crossvale, we have 3 workshops that we usually run with this. One is the Quarkus concepts, and this is just to go through dependency injection, writing unit tests, debugging, building native apps, etc., deploying to OpenShift. This is a module 1. Then the module 2, that is more to go a little bit deeper into, all right, now I know how to code an application. How do I code this into an event-driven application where I integrate with Kafka, or where I integrate with streams, or I want to see how to measure this with Prometheus and Grafana. I want to trace with Jaeger, etc. Or I want to use the JWT to use authorization in my application. The idea with this lab is to create an enterprise, or to show you how an enterprise application should look like. And then this other module or this other workshop is something that is more tailored for this workshop today, or this webinar today. That is how to go from a SpringBoot application into a Quarkus application. What do I do, or how do I do what I in Spring? How do I do it in Quarkus? This is not an automatic migration, or this is not something that we are going to take application and we are going to migrate it. We want to show you how to do the coding in Quarkus, of understanding how would you code in Spring. We start with an application running in Spring, and then we go through Quarkus on the same application, big monolith. Then we go into a microservice model of that same application. And so those are the workshops that we have. We can, let me see here 1 second. Let me check on time. Okay. And these are the workshops that we have, and we are great to get it done with you guys. If you want to do one today, we have one of them up, and you just have to go to tinyurl.com/QuarkusRocks. And then here you enter your email address, and as password, the password is OpenShift. Let me do this. I was testing this earlier, so my user is probably already in. Yeah, let me do it with a different browser. So when you come here, you put your user. I'm gonna put mine, alonso@crossvale.com, and then the password is OpenShift. It doesn't show. When you do this, it's gonna take you to this user, to this panel, and here you will have the 3 modules available to do your workshops. When you click on the workshop, I'm gonna click on the Quarkus for Spring developers. It's gonna take you to the instructions on how to do the workshop. I was testing, making sure that all the environment was up before the presentation. So here you follow it. Anytime that you click on a gray space, it's gonna do a copy. So if I click here, it's just copied it. I can just paste it. And then the workshop environment, this is running on OpenShift, and it's gonna be running on Code Ready Workspace. This is an Eclipse environment that is based on like an IntelliJ or VS Code. Like you see, this is a VS Code. I don't know if you're familiar with it, if you have worked with it before, but this is the same environment. Here, if you want to execute something, I'm on a MacBook, so I have to do Command-Shift-P to open the commands. And if you are on Windows, I think it's Control-P. It sets it somewhere here. When this is how you operate on the workshop, then you click on Next, and you can go through this workshop. And it will tell you what do you need to do, how to operate it, how to do what are you doing, this is the example, the pet clinic project, and this is what you're gonna have running. So once you have your user provision and you have your user, I'm user 1 right now. After I log in and this is my user, I can do this. I'm gonna open in a different browser because I'm using Brave here and I want to use Chrome. So to get started, access the code ready, just click on the link. I'm not gonna click on the link. So. All right, there you go. It's gonna appear like this. You just follow the instructions. I'm just gonna give you a couple of hints on things to watch out. Once you click on user 1, it's gonna load the workspace. There you go. So I have the code already downloaded, but to download it, you do command git clone. And now it says provide the URL, and the URL is here. Again, you just follow the instructions. And you should be good to go. Now it's gonna ask me where do you want to put it, and I'm not gonna download it again because I already did twice. When you click here on the select repository, and it's gonna download everything, and it's gonna appear like this. Now, the labs are gonna go through this. One thing that is easy, and we keep seeing people making mistakes, so just letting you know, is that there are, in the instruction, it tells you execute this on this project. Please pay attention on the project where you are clicking. So for instance, here it says, these are the projects that you have. So you have Quarkus Pet Clinic, the Pet Clinic Customer Service, the Vet Service, the Visit Service, and the Web. And then you have the Spring Pet Clinic. This is the Spring version. This is the Pet Clinic running on Quarkus, the monolith. And then we have this is the monolith on Quarkus. And then these are the microservices to run the same monolith, but in different microservices. But again, if you follow the labs, you will get there. Now, one thing also that people struggle is here that this says to open terminals. The open terminal here is on the right-hand side. Don't look for it here, it's just here. And here you have new terminal and login to OpenShift. There are one thing that usually fails to a couple of people in each webinar, that is the login to OpenShift, and it's because the session is expired. If that happens, just reload, just refresh, and it will work. All right, then make sure that you check out the proper branch, and I'm gonna give you the example how to get it done. So again, you just saw that I just did click here. Let me close this, close. So here, let's open a new terminal on my new environment, the environment that I downloaded. Okay. And I copy this, come here and execute. And it says already on OCP 410. So we are good to go. And now it says, let's run the clinic, the pet clinic from Spring. I'll show you how to do it. Just again, copy. This doesn't matter where you are, just execute. And now it's doing the build, it's downloaded all the dependencies, and this is a Spring application. This is not a Quarkus application. So once it's up, it's gonna tell me the application is up. This is the clip share, and again, this is running on OpenShift. I should have OpenShift open somewhere. I'll show you OpenShift in a minute. Okay, so it says a new process is listening on 8081, but this process is not currently an endpoint. Would you like to add a redirect to this port so it becomes available? Yes. And we say, let's open it. So here I have the two options, open it in a link, and it's gonna open it here, but I don't like that so much. I prefer to open it in a new tab. So I have the tab always open here, and this is my application. I can find owners, I can find veterinarians, I have an error page, I have a home, and that's it. Now, please start with the labs. Start operating on the labs. You saw how I just got here. If anybody has a question, please use the Q&A or the panel and send the question, and I will be glad to answer. The other thing that I wanted to show you, just in case you don't want to go through the workshop or you don't want to do the labs, if you want to start coding on your own, you go to code.quarkus.io or just quarkus.io. If you go to quarkus.io, it's going to automatically come here. You can do learning, you can join the community, and you can start coding. When you click on start coding, here, this is a way to create your own scaffold. So imagine that I want to work with Kafka, and I have a Camel Kafka project that I want to create. And I want to also access, I don't know, I want to use Panache to access MongoDB. All right, and I want to expose REST interface. So let's put REST DC XRS. Okay, and now I do generate application, and I do load the zip. Now to run it, I can run it on localhost. I can run it with everything that I need. It just creates the archetype for the application. But this is a great way to start. If you want to start coding application and doing your own labs and doing your own testing, it runs very easily. If you do the labs, you will see how easy is it to run. Quarkus enables Java for the non-JavaScript developers, for the non-Node.js developers. When you change an application and you want to see the changes in real time, Quarkus makes it possible with multiple ways of running the application. You can run it like production application, and that is just like a container running, is immutable, or you can run it in a developer mode. In a developer mode, any change that you do is instantly available to the application. So you don't have to recompile, you don't have to repush it, you don't have to do anything. You just test and run. Let's go through the first lab that demonstrate that, and then I'll let you go and do your own labs. So we had the application running with Spring, and we are now I'm on the lab 3 of the workshop. So if we go to this lab and it tells us to go to here, this is the what is Quarkus. Please read all this documentation it is great. This is what it does, the live development. So we are gonna do a build in dev using the dev perspective. We are gonna run it on this container. In this case, this is not my local host. This is the container where this is running. So this is running in OpenShift already. And then we are gonna put it in this context. So let's go here and go to the terminal. Oh, I was using the other, sorry. Here. Let's open a new terminal on lab 1. To me, it asks which workspace I want to use because I have 2. To you, it shouldn't ask. It should directly put you to this other workspace. I use this to do a dry run of the labs to make sure that they were working. All right, so now we are gonna do a build of the Quarkus application. And we are using the Quarkus Pet Clinic, this project that I have highlighted. So now it's doing the build of this application, and now it's running. And it says, this is now running on port 8080. Do you want to open it? Let's open it in a new tab. So I have now the same application, but it's running on Quarkus. So this is running on a Spring, and this is running on Quarkus. Let's take a look at the application, and the lab goes through the details of what the application is and what is the difference between one and the other. Let's work on the capabilities of the live demo. I don't know why. Quarkus. Okay. Yeah. This started the wrong project. It started the one that I have built already. So let's push this, and this is labs 1. So I did a dry run before, so it's pulling from the one I have already modified here. So let's change it to use this other workspace, that is 1. Okay. Let's open up a new tab. Sometimes this happens. Don't panic. Just do a reload. Okay, great. So my new application is up and is ready. And this is a default page from Quarkus. Great. How do I change this? So let's go through the change. It says, go here to the templates and modify this template. Okay. So let's copy this, and we go to change the welcome HTML on the SRC main resources template of that project. Again, this is one of the things that makes the most issues. Pay attention to the project that you are changing. So it is on main resources meta templates. And it's on welcome. There. We save it. Now it says this is done. And what it's doing is including the header doing a body, and then including the footer. Those are two other templates. You see them here. This is the footer, and this is the header. Okay. So now let's change the application to pull that page. Let's inject it. And it says, go to the welcome resource.java that is inside of this project. Okay, so we go to C, Java, Quest, welcome resource. And here, what did you say to do? Do the inject. And then let's add the get. We do the get. Okay. And let's remove the index HTML. That is the default, because otherwise you're just gonna keep pushing to it. So I don't like removing because sometimes you want to go and look at something. So I just rename it. Okay. So now here, as we save, we should be able to go to our pet clinic, not this one, do a reload. And now we have Quarkus. I have not recompiled, I have not done anything. I was just coding and I can see results directly. As I keep changing things and the lab will get you through it, as you keep changing things, you will see how the changes are immediately taken by the application and you can see them live. Okay. So please go through the labs, raise your hand if you have a question or if you need some help, and I will make sure to help you. The labs are pretty easy and it goes in details about why you're changing what you're changing. Please read the documentation, read the text that is associated to it, and get started with the labs. We are not going to have enough time for you to finish it, so get familiar with the environment. The environment is going to be up for 12 more hours at least. Get started with it. And if you have a question or if you want us to do this more ad hoc or more in detail or more guided, please let us know and we can schedule an in-depth workshop for you or your company. And we will spend more time on any of the questions that you may have or your particular use case. So I'm going to stop my share now. You have your labs, you have the documentation, and you have the environment. Please let me know if you have any question. Okay, and I'm gonna go mute. I'll ask again in 15 minutes to make sure that everybody is flowing along.
So I think one of the questions was how long is the lab going to be available? I believe in speaking with Red Hat, it'll be available for the next 24 hours. So that's how long the lab will be able for you to run through it.
Yeah, the whole workshop for a normal user, the first time running, is going to take about 3 hours to run, depending on of course, on how proficient you are. Some people do it in an hour and a half, but the average or standard is about 2.5 to 3 hours.
Yeah, and as Jose mentioned, some ways to engage with Crossvale around this is like we can dive deep with your team to do customized workshops on, and scope that out for you guys. We can do POCs around this as well. And then the one I mentioned before is assessments, and we can see where you're at today and where you want to go and help get you guys there as well. Jose mentioned a couple other resources to check in on and follow up on. But I would like to thank Red Hat for their continued partnership with Crossvale to help us to put the lab out there as well.